All right, ladies and gentlemen, we are going to get started today. We're going to talk through a bunch of stuff, just kind of a heads up as to where we're at. First of all, for those of you that have decided to do retakes of the quiz, I think that's going pretty well. I've got plans for most of you. I spent a little bit of time last night during conferences looking at where grades were because I literally had before just kind of put things in and just let it sit there. If you've got a D or an F, I'm going to come hunt you down at some point because I really do want you to go through this. I really do want you to go through the retake and relearning process because everything that we do for the rest of the year is going to build on this. And I want you to feel confident, or at least mostly confident about what you're doing so that we can move forward in a positive way. So if you did not come to do reteaching already, but you would like to do that, I'm going to open that up. I would like for you to do that. I would love to have you in here. I am free, as you know, before school. I would say reliably by 8:20 I'm here. Third period, seventh period, Liberty time. After school is a little bit hit or miss, but if you make arrangements with me, we can make it work, okay? So please think about that if you are in that boat. If you're not sure, you can check Power School, of course. Come talk to me. We'll get it figured out. Questions about that stuff? If you've already taken a retake, I have not graded those. I'm going to do that this weekend once I've got a large number of them. So just sit tight for that. Know that I have not forgotten about it for sure. Okay, taking a look at our plan for the day today and what we're going to do, we are going to move on. We're going to do some more graphing because that graphing is important. That graphing that we started with yesterday is where I want to keep moving. I am recording every day, so if you need to go back through and watch this again or watch a piece of it, please do that. Take advantage of that resource. Or just come in with me and we can talk it through again anytime. So we're going to graph first, then we're going to go over the homework. All the homework questions were very similar to the example that we did in class yesterday. So if you were here yesterday, they should be similar. Finding VI. Then we're going to do a couple of practices of finding the DX. That's kind of the other way to solve these problems or to be posed with those problems. Tomorrow, we are going to quiz over this process. Okay? It's going to be a half-sheet quiz. There's going to be 3 questions. One of them will be a graphing problem, kind of like the one you saw yesterday, kind of like the one we're going to do in just a minute. Okay? Understanding how graphing works with projectile motion. And then there are going to be 2 other problems. One is going to be a find VI problem, which is exactly like what you did in class yesterday and that we're going to do today. And there's going to be one finding DX problem. Does that make sense to everybody? Issues or questions so far? Okay. So I want everybody to pull notes out. I want everybody to be paying attention. So put the homework away if you're working on it or whatever. I want you to take a look at this question right here. Projectile motion for 2 rocks. Ladies and gentlemen, this is very similar to what we did yesterday, but it's not exactly the same. So I do need you to think this through a little bit. It says, 2 identical rocks are thrown horizontally from a cliff. So they're both thrown horizontally. Rock A has a greater velocity at the instant it is released than rock B. But all of that velocity is horizontal. It says to use the coordinate system, I'm going to change this because I feel like it's a little bit confusing. We're going to say down is negative. We're just going to do what we normally do. So we're going to say that this is positive and this is negative. This is positive and this is negative, just like we would normally. They have it written a different way in the question. Thank you. But I just want to make sure that makes sense. Blah, blah, blah. So positive is for the cliff. If we draw a picture of the cliff, our axis is going to be positive this way and positive this way. The first question is part A, to sketch velocity versus time graphs for each of the rocks. So rock A is the one that has been thrown faster. And again, all of these launches are exactly horizontal. So it's going straight that way. Oh, he went under the thing. That's pretty funny. Okay, straight horizontal. Rock A is being thrown faster than rock B. Does that setup make sense? Yeah. Okay, I'm going to let you work for a couple minutes. You can talk to each other. That's absolutely fine. Yeah. Yeah, hold on just a second. I'll come over back. Yeah. Yeah. All right. So get started. You can talk to each other, write down a sketch, and then we'll talk in just a sec. All right. So let's take a look, ladies and gentlemen. You think you've got something. One of these should look a lot like what we did yesterday, right? Yeah. So let's pick one. Mira, which one do you want to do, A or B? A. And do you want to do the horizontal or the vertical part of A? She's like, vertical, let's do it. Because it's the easy one. All right.
It'd just be going with the slope down, starting at 0 to the negative 9.8.
Yeah.
And the same along with the B because they're the same for gravity.
She's like, I'm just going to do the whole thing. Yes, that's awesome. Yeah. So in both cases, for both of those rocks or balls or frogs or whatever it is, the vertical part is going to be just starting at 0, right? Because in the vertical direction, it just starts from rest, and then it's going to accelerate downward. That's awesome. That's it. And the slope of that line represents, what did you say? Or the slope of the line is what? Indeed. Yeah. So the slope in both cases is negative 9.8 meters per second squared, which is the acceleration. Is that okay so far? Same. And in fact, these look just like if I took my frog and dropped him straight down, right? Because that motion is always the same. Okay, we got the vertical stuff done. Who's got horizontal stuff to talk about? You can just do one of them, even. Alex, what'd you guys say for the horizontal?
It was constant positive.
Constant positive? Yeah. Constant positive. All right, let's do it. So constant positive, here it comes. Okay. Oh. If that's what we say for rock A, is rock B going to look exactly the same? It's going to be a little bit different. What's it going to look like?
A little bit lower.
It's going to be a little bit lower. Why do you say?
Because it's slower than
I love this, you guys. This is awesome. Something like that? Yeah. So the velocity for rock A is going to be higher. The velocity for rock B is going to be lower, but they're both positive and they're both constant. Life is awesome. Excellent. So now I'm going to give you the two other questions that go with this. So it's the same picture. I'll draw the graphs. Here are the other two questions. So B and C. Take a look here at those two questions. See if you can answer them. I'll draw draw the graphs that you just told me to again, so you can refer to them if you need to. And you are welcome to just talk to each other if you want, or if you want to do it individually first, that's fine. How's our level of confidence on this one? Feeling okay-ish? Pretty low, is that what you said?
I'm giving her.
Pretty low? I appreciate the honest answer. That's what I need, because as a teacher, I'm like, I know this stuff. Why don't you guys know it? So let's go through it. Let's do it. All right. Let's answer question B first. Which rock is going to hit the ground first? Should we vote? Who thinks it's going to be A? Who thinks it's going to be B? Who hasn't voted yet? Why haven't you voted yet? Is it because you don't know or because you want to do something different?
It's a lot. Because
Motion.
I feel so.
Isn't it gonna hit the ground soon?
Yeah.
Same
Same time.
Same time, this one says.
Same time.
I hear some same time grumblings here. Do you guys agree with that same time?
That's what I was thinking.
That's what your gut said. So I don't have my fancy little device that I had from before, the one that we used, right? It only can hit one sphere on this direction at a time. But let's just think it through. If you drop one and you kick one, which one hits the ground first? Same time, right? And why is it the same time when you have one that's dropped and one that's kicked? They have the same acceleration in the which direction? The Y direction, right? Yeah. And and what did you say?
The motion in the X direction does not affect the motion.
The motion in the X direction does not affect the motion in the Y direction. So rock A and B now, both are going to be kicked this way. But do they have any difference in their motion in the Y direction at all? They both start off at 0. They both have the same acceleration. Is that making sense? Sometimes our gut tells us, well, the one that's going to go farther has got to take longer, right? That's what your gut tells you. I know, and I totally get it, right? Because it makes sense. If it's going farther, it's got to take longer. But the funny thing is, and the reason we spend all this time with this is because the Y stuff has nothing to do with the X stuff, right? The motion in the X doesn't affect the motion in the Y. So even if you've got one that goes really far and one that goes, which one's going to hit the ground first? Right?
Good question.
It is kind of a trick question. It's not worded in a very nice way for you to actually answer the question, because the answer should be that they're going to hit at the same time. They're going to hit at the same time because the motion in the X does not affect the Y. If you don't believe me because you're like, I don't think that sounds quite right, Ms. Carlin, that seems kind of fishy, there's another way you can show it or prove it a little bit more mathematically if you prefer. Trying to get these lines to be drawn parallel to one another so they look really nice. Do you remember that little half green sheet that we did when we were talking about graphing? And we said that if you're going from displacement to velocity, you can look at slope. Or if you're going from velocity to acceleration, you can look at slope. Do you remember this? But we also said that you can go backwards. You can go backwards by looking at the area. We kind of talked about that a little bit by looking at the area. So if we look at this, and again, my pictures are not perfect, but give me a little bit of space, because again, these pictures are not, the lines are not parallel. But this area here, is the displacement. And this area here, how should they compare? How should the areas compare? They should be equal. If they have the same line and you're going to the same amount of time, the areas should be equal. Displacement in the Y direction. They're going to go the same distance in the same amount of time because they have the same area. So that's another, like a graphical way to explain that if the gut feeling or the demo doesn't seem to match what the right answer is. Okay, that's the graphical explanation. Which did you say for C? Which rock lands farthest from the base of the cliff? Emma, what did you guys say over here?
That rock A lands farthest from the base of the cliff because it has more of the velocity in the next direction, like it's going further. Like the velocity is faster, throwing it farther outward.
Absolutely. Yeah. So if you remember thinking back, we know D equals V over T, right? In the X direction because there's no acceleration. If we solve that for D, we can say that the displacement in the X is equal to the velocity in the X times time. If they're going to take the same amount of time, one has a higher velocity, it's going to have a higher displacement. Are you with me there? So that would be like the algebraic explanation for the lovely answer that Emma just gave. Another way you could do it, if you like the graph, you can also do it that way. You can say, I can find the area of this rectangle. Even just looking at it, which one has a bigger area? A, right? A does. A has a bigger area, which means that it's going to go farther in the X direction in that same amount of time. How are we doing?
Good.
Doing okay? Kind of feeling it? Awesome. All right. I wanted to look at the homework problems. I wanted to go through them if you have questions and answer them. I want to do at least one of them to make sure that we're feeling good before we move on. I just put the answers up on Canvas. I'm sorry that I didn't have them up last night. That was my bad. But let's go through them and I can tell you the answers for sure. Then we'll see how we did. And if you want to go through multiples of them, we certainly can. So this was on page 99. Does that sound correct to you? And we did 1 through 3, I think. So here are the answers real quick, so in case you need them. Question 1, the answer was 0.66 meters per second. Question 2, the answer was 4.9 meters per second. And question 3, the answer was 7.6 meters per second. I asked someone this morning, I think it was someone in the other class, but I can't remember for sure, how the homework went. They were coming in to take their retake. And the person said, well, it's pretty much like the problem that you did in class. It was, right? It's the same setup in each case. So if you have questions, again, we can look back to the one that we did yesterday. I'm happy to go through one if you guys would like. Would you like to go through one of these to make sure that we're feeling good? Yes, Miss Carmeling? Or no, that's okay. You tell me. Yeah, let's go through one. Hey, can we do number 3 if we're going to pick one? Is that okay? Just because with the pelican? Yeah, the pelican. For a couple of reasons. For one reason, I just really like it. And I'll tell you the other reason in a second. Why don't you guys go grab books? Because we're going to go through a couple of them, and I want to make sure that you see it. You have it. That's not what I was thinking. I haven't seen Finding Nemo for ages because my kids are like, I don't know, we just haven't put that one on our list. I know. I love that look. Did you listen to Sing 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 last night, though? And did you watch that movie? I'm just saying.
I've seen the movie.
We watched it. We watched the video with that song last night. I thought of you guys. I was like, oh, yeah. It's good.
Finding Nemo.
Finding Nemo is a good movie. I agree. To the fact that I do have all of the answers for the rest of this stuff up on Canvas now. So I put them up. But like I said, I just did it during third period. So I apologize that it wasn't there. But those are there. And then the answers for tonight's homework are here too. So just wanted to let you know that they're there. Okay, so let's take a look at question number 3. And then we'll kind of get a feel for where we're at. And if you guys want to go through more, we certainly can. So I'm going to write out question number 3 from page 99. Y'all are going to help me with it. And then we got to cruise on and we're going to do number 4 also, even though it wasn't assigned. What? All right. It says a pelican is flying along a horizontal path, drops a fish from a height of 5.4 meters. The fish travels 8 meters horizontally before it hits the water below. What is the pelican's speed? So the reason I like this problem is that it's actually quite realistic. My husband used to he grew up in Davenport. So he used to do marching band where you guys are playing tonight. So hopefully his mojo will help you there too. And so Davenport is right on the Mississippi River. And there are a lot of eagles that fly around in the Mississippi River. And he was outside one day playing with his dog. I don't know, he was probably 7 or 8. And he was just playing in his yard. And all of a sudden, a fish literally dropped from the sky. Like a big fish dropped from, he's like, what? And he looked up and there was an eagle that was flying past. And like, obviously had, I don't know, decided not to eat that fish or got distracted. I don't know how eagles work, like how their brains work. But apparently didn't want that fish. So his dog got to devour it, which is kind of a sad story. But anyway, it happens. That's the point of the story. All right, let's draw a picture of a pelican. I haven't gotten to draw a pelican for a long time. You can draw a pelican too. Yeah? And there's the fish in the pelican's mouth. And the pelican is flying along. And there's water below. And so as this pelican is flying along, the pelican's just flying. He's going to let go of that fish. And that fish is just going to zoom. So you can draw the trajectory of that fish as it falls. Is it going to fall straight down to the water right below where he dropped it? It's going to droop. It's going to make what kind of a shape? Starts with a P. It's a parabola. Yeah, it is. Splash. Was it Malik that was making the noises yesterday? I'm missing that now. So sad. Yeah, so it's gonna make that splashing sound. We know some information. It says that the pelican is dropping a fish from a height of, was that 5.4 meters? Is that what it said? Okay. And it said that the fish travels, oh, this is really not drawn to scale. Sorry about that, friends. Apologies right now. Because it moves 8 meters horizontally. I should have read that more carefully before I drew my picture. Yeah, my 5.4 is a little bit bigger than my 8. I apologize. It says, what is the pelican's speed? So after you've drawn your picture and you've drawn your distance in the X and distance in the Y, then you need to have an initial arrow. Okay? Okay. So where is that initial velocity arrow going to go? Initial velocity of the fish. Is it going down? Is it going out? Is it going up? Is it going at some angle? Really look at me a little bit crazy. Just like in the last one we did yesterday. Initial velocity is directly in this direction. Initial velocity is horizontal. All of the problems that we're doing today, the initial velocity is going to be horizontal. Today. Yeah, because you don't know because you weren't there last Thursday that we launched stuff at angles. So next week we will do angles, but not today. Okay. Today and for the rest of this week, all the projectiles are going to be horizontal. So you're safe for now. When you come back on Monday, no promises. But all right, let's write down some givens. We're going to do Carbling's patented givens chart. Here it comes. We're going to write down all of the X stuff. dx, vx, ax, and all the y stuff, dy, vy, ay, and the thing that ties it all together is time. Okay. Fill in something for me. Who's got something? Go ahead. Vx or dx is 8.0 meters? Yep. Awesome. One down. A few more to go. What you got? Awesome. Did you guys catch what she said? She didn't just say 5.4. What did she say? Negative 5.4 because it's going down, right? Negative 5.4 meters. Yeah. All right. What else you got? Tell me more. Tell me more. There's all these songs that we go. Yeah.
Our initial in the y is 0 meters per second.
Initial velocity in the y is 0 because it's just fallen from rest in the y direction. I'm going to try and share the love because you told me one already. Go, Jordan.
Is the acceleration x going to be 0?
It is. Every single time, friends. Every single time. This is like locked. This one will always be that free answer right there. You're welcome. Constant speed, no acceleration, no parachutes, no rocket ships. Not today. What else you got?
Acceleration y is negative 9.81.
Indeed. Guess what? That one's locked too. So that one's easy. Always and forever. And so then Isaac might put a box around this one, but only for this week. Right? Next week, that's not true. But for this week, VIY is going to be 0 because it's a horizontal launch. Okay? So really, I'm not going to put a box around it because I don't want to pick like, yeah. All right. You're there. Now we just got to plug stuff in, right? Because we got one equation that all of these problems are going to use. It's the one that you know and love the most. It's the big, long, scary one. We got it. We got it. Here it comes. You guys know it, right? I feel like I need a song for it or something, some little theme. D-Y, V-I-Y-T. I'm trying to come up with some sort of catchy jingle in my head, but it's not coming. So I'm just going to stop singing. But that's the equation. So far, so good? We want to be clever. We want to make our life better. Is there anything that goes to 0 in that equation? VIY? goes to 0. Catch you later. All right, we got dy is equal to 1/2 AYT. I didn't really mention, for those of you that are like, what's going on? I didn't really mention, why are we doing this? Oh yeah, what are we trying to find in this problem? This is the big question mark, right? It says, how fast is the pelican moving, or how fast was the fish? Oh, it does say, what was the pelican's speed? So that's what we're asking for. But we don't have enough information in the x to find it. What do you need? You need time. And the only way to find time is to use the y stuff. So again, the motivation behind this, we're going to use y stuff to find time, use time to find vx. Okay? So here we go. We got dy is 1/2 AYT. Oh, squared. Why did I not write it squared? Silly Miss Carbling. Jeez, that was embarrassing. Don't tell anybody. I'm recording this. Shh, don't tell. Shh, it's a secret. We want to solve that for time. Can you do it?
Yeah.
Yep, I can. What do I do first? You get time by itself. That seems like a reasonable idea. Trying to get TL by itself, so it's kind of like peeling an onion. You take everything off until all you've got left is the middle, right? So 1/2 AY, we're going to divide that because right now we're multiplying by 1/2 AY. So now we're going to divide by 1/2 AY to get rid of that. Then you've got just t squared on one side. How do you undo t squared? Square root. So I'm going to write that out really nicely so we can see it. T is equal to the square root, some people say in Iowa. It's funny. They can like pinpoint you to exactly where you're from based on how you say that. Did you know that? That and the top of a house, is it a roof or a roof? Can tell exactly where you're from. Those things, it's kind of scary. Plug in your dy, plug in your ay. Plug that in right now. I want everybody to do this because you're going to have the opportunity to do this tomorrow also. But better to do it now and make sure you know what you're doing, since I'm not going to double check you right away on your quiz tomorrow. Not until after you've turned it in. So everybody's got a calculator. Does anybody need one? Who needs me to bring up a calculator? I'm happy to do it. I see one hand. Anybody else? Who else got one? Everybody's doing physics right now. Tell you guys, it's all good music. Once you've got that time, you can write it into the givens chart. And then you can solve the Vx part if you want. What are we getting for time? 1.05, is that what you said?
Yeah.
So plug that in here. And then we're going to do the dx part, so here it comes. Same equation, just subscripts of x. We get excited because there's more zeros, right? I love zero. I need like a whole wardrobe of shirts. One with this equation on it, one that just says I love zero. Be good things. Is there anything that goes to zero in the x equation? What is it?
1/2 ax t squared.
Indeed, that whole big nasty part goes to zero. So then you've just got dx equals vix times time. Vix equals dx over t. How are we doing? Are we doing okay? Plug in those numbers. Did you get 7.6? Excellent. Tomorrow, when you have an opportunity to do this on a quiz, I'm just going to let you know the way that I'm going to grade it. I don't know exactly the points because I want to make it all about the same as all of your other things, but I would think it would probably be a point for this. So we'll call it 1, 2, 3, 4, 5, 6, 7, and an 8th point somewhere. Right? Are you with me there? Like that would be like I'm looking for this. Looking for your givens. Absolutely for sure. Without a doubt. Looking for your big equation, your algebra, and I'll give you a point for just finding the time. Okay? Having your other big equation and your answer. Okay. So the quiz will be, I put it up here. Hold on just a second. Can I flip from this? Is that okay for a second? The homework quiz is going to have 3 problems. One is going to be a graphing question, kind of like the one that we did at the beginning of yesterday and the beginning of today. So I can show you that again. I don't remember when you walked in, if you saw that or not. And then there's going to be a find VI problem, and then there's going to be a find DX problem, which is what we're going to do next. It's almost the same. Does that make sense? Sweet. Okay. How are we feeling with this? On a scale of 1 to 5, 5 saying, give me the quiz now, I'm ready to go. 1 saying, I don't know what a projectile is. Where are you at? Yes. This guy?
Yes.
Let me tell you. And then I'll let you vote, because I see some hands and I want to know, but I want to answer this question. I want to throw that in. So are you okay with this equation that I have here?
Yeah.
Fabulous. So then we're going to do the square root, depending on where you're from, I suppose, negative 5.4 meters divided by 1/2 times negative 9.8 meters per second squared.
That's it.
That's it. Does that work? All right. All right, now I want you to vote. How are we feeling? 5 is, I love this, give me a quiz right now. 1 is, I don't know what a projectile is. You show me on your hand. Put it up in the air, let me see it. I'm just kind of curious as to where you're at. If you're feeling like you're a 3 or a 4, then you're going to practice tonight, right? Do some practice. You might be there. You need to just hold your practice. If you're feeling like you're a 1 or a 2, then let's talk at some point before tomorrow. Does that make sense? If you want to just come up right after class, like let's find a time so that you feel good about it. Okay? Now we're going to look at question 4. Question 4 was not on your homework, but question 4 is darn for sure going to help you on your quiz tomorrow. It says if the pelican in item 3 was traveling the same speed, but instead of being 5.4 meters up, was only 2.7 meters up, how far would the fish travel horizontally? Okay? I'm going to move this. Is that okay with everybody? Okay, I'm going to move this down here. I'm going to put a brand new problem. We're going to start it over. We'll draw a new pelican and everything. So this is page 99. This is question 4 from that set of homework, except it wasn't on your homework. We're going to just do it right now. So we're going to draw ourselves a pelican, mostly because I like to draw pelicans, not going to lie. And I'm going to put a fish in his mouth, or her mouth. Guess I shouldn't assume. Can't make assumptions. And there's the water. Now the water's a lot closer. The distance in the y direction is what? 2.7. Do we know the distance in the x?
We're trying to figure that out.
We don't. So I'm just going to write it as dx equals question mark. Okay? I'm going to go ahead and draw that trajectory because I still know that it's going to be a parabola. Doesn't have to be at any sort of scale, but just get a parabola there so I know what it looks like. And then I'm going to go ahead and draw in that initial velocity as well. Where is that initial velocity going? Straight across, right? And do we know the initial velocity in the x direction? We do, because we just found it. 7.6 meters per second. Okay? Once you got the picture, remember guess has a silent P at the top, right? To guess, I don't know. I think it's a silent P. But it's picture and then write down your givens. So we're going to write down the givens chart. Here it comes. So we've got our x stuff, dx, vix, ax. In the y, we've got dy, viy, ay. And the thing that pulls it all together is? That was not resounding. We're going to try that again. Y'all were just writing, and so you weren't paying attention to the question. I know that's what it was. Let's try one more time. The thing that holds it all together is?
Time.
Oh, that was much better.
So that changes also those two.
The time will be different. Why will the time be different?
Different y.
Different height. Every time you have a different height, you're going to have a different time. Just like when we were doing the free fall lab. Do you remember? We dropped the ball. When you drop the ball from a different height, you're going to get a different time. That's exactly right. So all of that work we did in the other one, well, it doesn't mean nothing, but it doesn't help us with this.
Yeah.
We do, yeah. So now we're going to fill in our givens. Remember, I told you there were a couple of easy givens. So tell me, raise your hand if you got a given. You can do an easy one. You can do a hard one. I don't care. Go, Stella.
X is 0.
AX is 0. She's like, I got that. No problem. Boom. What else you got? Go. I love that you're just embracing the dy. You're like, I got this. And it's negative. Don't forget that negative. I know she's not going to forget it, but make sure none of you forget that. That negative is important. Absolutely. What else you got? Go, Emma. Indeed it is. AY is negative 9.8 meters per second squared. We're almost there. I think there are 2 more things you can fill in. Yes, it is. VIX is 7.6 meters per second. Fantastic. You look a little confused there, Stella. Are you okay with that? Okay. You can say no if you're not. So you want me to talk or no? You happy? Okay. Anybody else want me to talk about that? Y'all happy? What's VIY? 0. So this problem seems different because we're looking for something different. But if you look at this from a big picture perspective, what's the first thing you have to find, ladies and gentlemen? T. And that process is exactly the same as you did before. It's going to be a different time because they're at a different height. You with me there? But it's the same problem with the same awesome equation to start, right? You got this. This is no big deal. We're just going over it over and over. dy equals vyt plus 1/2 ayt squared. Does anything go to 0? Yes. What goes to 0?
BY.
Indeed it does. So you've got dy is equal to 1/2 ayt squared. Do you feel like you've done this before? It's because you have. Do the algebra. We're going to divide by 1/2 ay. We're going to divide by 1/2 ay. Am I going too fast for you, friends? Or are you doing okay? You may say slow down. We're okay? All right, let's keep it cruising then. You should be moving your pencil too. Get rid of my t squared by taking the square root. So we've got t is equal to the square root of dy over 1/2 ay. Hey, before you do it, do you think the time is going to be bigger or smaller for this one than the other one?
We decreased our height, didn't we?
I think so. Let's double check because I don't actually remember. It was 2.7 now and it was 5.4 before. Yeah, so we've decreased our height.
I'm pretty sure it's going to get smaller time.
I'm thinking it's going to get smaller time. It's going to take less time to fall a shorter distance, right? Does that make sense? Yeah. So hopefully you get something less than 1.05. If you don't, it's probably because you didn't take the square root. I'm thinking. So what'd you get? 0.74? Other people want to corroborate that? That means agree with. Just making sure. I always use big words with my kids and they're like, what does that mean? I'm like, oh, yeah, I'll tell you. Build your vocabulary. dx equals vixt plus 1/2 axt squared. If we're happy and we know it because we can get something to 0. Thank you. What is it that goes to 0? Acceleration term, that big, nasty, scary one. Hey, and look, you don't do any algebra for this. It's just there. You just plug it in. It's beautiful. 0.76 meters per second times, it was 0.74 seconds. Boom and pow, what'd you get? Something. Is it going to go as far or is it going to go? What do you think? How are we doing? Okay-ish? Did you get an answer? You still working? Does anybody have an answer yet? What'd you say? 5.6? Yeah. What's up?
I'm not getting.
Here? I'll come back and help you. Let me come peek.
So you need to make sure that you have parentheses and because what it's doing right now is 2.7 divided by 0.5. It's doing that, and then it's multiplying it by parentheses. So let's make sure that we're not starting with parentheses.
No, I don't think so. I tried.
Then you get 0.5 by parentheses, right?
Yeah.
Yeah. Yeah, so make sure that you have it,
I think my jaw's already.
and then
Do you have brains in them?
so
Yeah,
if
I think I-
parentheses are not.
Okay, I thought I did too.
So then, yeah, so then divide, and then
It
put open parentheses.
so bad.
Nope, so yeah, divide, you can do divide by that, yeah, and then you do the other side. And, does that make sense?
Because it was trying to
And then get myself on the table.
do this division first and then multiply. Did you get it? Okay. All right. So, ladies and gentlemen, the problems that you have for homework tonight are over this kind of problem. There's one thing that I want to point out to you because I don't want you to run screaming from it. Actually, question 31 is kind of like the other ones that you did yesterday. Question 33 is like the one we just did, the Pelican. Okay? It's just two boats that are both going over a waterfall. So it's really a sneaky way to do two problems in one. And then you're going to subtract their distances to find the answer. So that 11 meters is going to be subtracting the other
They
two.
go over the waterfall?
Yeah, it's a speedboat going over like a small waterfall, and then there's like a police boat that's following it. It's really exciting. I know. It's like some sort of movie or something.